here we go.
I have 3 months of Spotify Premium.
And we're live. Welcome to Mr. Mac's math class. We just completed the 5 essentials. Let me tell you, very essential. All right. Isosceles triangle theorem. First off, let's talk about what an isosceles triangle is. So, an isosceles triangle, so you remember the C,
I put those away yesterday.
is a triangle with 2 sides that are congruent. As you can see, I have constructed an isosceles triangle by creating 2 congruent sides. Now, pop quiz. Is this an isosceles triangle?
No.
Does anyone say yes? All right, why is it not?
Because it's equilateral. Because there's 3 sides that are like equal.
Okay, sure, that's a good thing. Because it's equilateral, that's true, it is an equilateral triangle. Who said yes, they are the same? No one? Okay. So guess what? He doesn't know why he's right, but he is right. Turns out that this triangle right here and this triangle right here are both isosceles because 2 sides are the same. Now this one has 3 sides, but it just gets extra credit, right?
Yeah.
That's it.
It's, like
It's still isosceles. Now, when we think isosceles, which one are we talking about? 90% of the time this one, right? Notice that an equilateral triangle is isosceles, but an isosceles triangle is not necessarily equilateral, right? Here's an example of an isosceles that isn't an equilateral, right? Now, again, 99% of the time when I say isosceles, I want you to picture this, okay? Equilateral, all sides and all angles are the same. Cool. Now, it turns out isosceles triangles have a theorem about them. And the theorem is that if 2 sides of a triangle are congruent, aka if you have an isosceles triangle, right?
Really?
Then the angles opposite those sides are congruent. So what that's saying is that if you have 2 sides that are congruent on a triangle, then their opposite angles are congruent. So see how this side is across from this angle? So that's the opposite angle. Does that make sense? So if this side and this side are the same, then this angle and this angle are the same. There's a theorem. Now, what's the difference between a theorem and a postulate? Anybody know? Great. A theorem is provable. A postulate is leap of faith. It's something we accept to be true because how could it be anything else, right? That's a postulate. This is a theorem, which means it's provable. So what we're going to do is we're going to prove that theorem to show that we can, right? And just like when you do like a definition of something, you can't use the word in the definition, right? You can't use the theorem in the proof of the theorem. Does that make sense? Right? You can't say this theorem is true because look, this theorem says it's true. That doesn't work. So we're going to prove that whenever you have 2 sides of a triangle congruent, then their opposite angles are congruent. And we're also going to prove the converse of that. Converse just means we're going to flip it around. So 2 sides of a triangle congruent. So if I have a triangle and I have this, that means that that same triangle has this true about it. That's all that means. Now it turns out the converse is also true for this, and we're going to prove the converse on the back page, which means that the arrow goes both ways. Meaning that if we start with angles, then we get this too, right? So if we start with angles, then we know that the sides are congruent. And again, it goes both ways, right? That's the forward, that's the backwards, right? Everybody cool with the idea of a converse to a theorem? Right, it's flipping the 2. You take, if 2 sides of a triangle are congruent, then the angles opposite those sides are congruent. And you flip these 2 things. If the angles opposite those sides are congruent, then the triangle's sides are congruent. So we're going to write that. If 2 angles are congruent, right, I'm just flipping these things, right? That's what the converse is. If 2 angles are congruent, then which sides? How do we identify which sides? It's not just any sides, right? It's not going to be these 2 sides. It's the opposite sides, right? Right? Does everybody understand the idea of a converse, right? You have a statement, and then you can kind of flip it around. Not always will the converse be true. Okay? But in this case, it does go both ways. Some theorems do, and that's okay. Their hands back there laughing. All right, so now we're going to prove the theorem. So remember, the theorem says that if the sides are congruent, then the angles are congruent, right? So they're saying, given a random triangle, which I drew for you to make it look like isosceles, but I didn't have to. CA congruent to CB, right? If they gave us that, we're going to prove that the angles are congruent, right? That's the theorem, right? If you have this, you should be able to say the angles are the same. Now, eventually, in order to prove that, we'll just write by triangle, isosceles triangle theorem, AB is congruent to, or A is congruent to B, right? Call it a day. But for now, we're going to prove that that theorem works. So it's going to feel weird. I will back it up and go over it a couple times, right? Like a dead cat.
What?
Right?
Oh my god.
So don't worry. Just pay attention the first time. You don't want to miss the first time, right?
You were too dark.
Okay, so let's start. First off, there's a postulate I didn't tell you about. You have magical powers. You guys ever seen Matilda?
Yes, that's my childhood. Getting a choking.
Exactly. That's right. So
Isn't her only thing she
I need to
can do
make
is,
one of
like,
those
turn
into a
on
choky.
lights?
Did
All
she
right.
have to eat a whole chocolate cake or something?
Nope, that was the other kid. What was the name of that kid?
What? The kid who ate the chocolate cake?
Yeah.
Hank, Angus.
Nope.
Lord ass.
Angus. It was
He kind of
Angus.
looks like Angus Young.
It was
from AC/DC.
Angus.
Nope, Bruce.
Bruce.
Bruce. Come on.
I just think it was
I
shocking.
thought that was in like
Why is this huge quote that movie? They watched it
I
bottle
hate
shot
the movie.
47 times.
It's awful.
My mom always yells what chocolate is.
All right. Because I have sinus pressure, my right eye feels like it's gonna pop out of my head. If it does, we're just gonna keep going. All right.
Bruh, eat some chili.
So, you have magical powers. And one of your powers, one of the postulates that we have not known about, we're going to call it let there be line postulate. And this lets you create a line wherever you want. Flipendo, right? And you can create a line. And not only can you create a line, but you can say, and I declare that line to be perpendicular to another one. So we're going to say this. Let there be
To continuously quote my parents.
CD perpendicular to AB. Whoa. What is going on here? Well, what we're saying is we're going to create a line segment, CD, and we're going to have it be perpendicular to AB. So let's put that on our diagram. We are allowed to create this wherever we want. Now, I'm not going to measure it out, because you don't need to. You can just say it is. So there's my line segment, CD. And I said it's perp, as in perpendicular. Ta-da! So I let there be line. Let there be perpendicular line. Did it. And this is going to help me prove what I want. To prove that angle A and angle B are congruent. Everything good so far? Rad. So next thing we're going to do is try to get as much information in this diagram as possible. That's what I'm doing right now. I'm collecting clues. Okay? And then we're going to prove the triangle's congruent, the left one and the right one. And then their parts are going to match up. Okay? So let's get as much information as we can. Is there anything else I can add to this diagram to help me out? Anything that you see?
Shared angles.
Shared angles? What do you mean shared angles?
Lines.
Shared line? Shared side. Shared side. Yeah. Right here is shared between both triangles. So I'm going to write that. By shared side, that's a postulate. By shared side, CD congruent to CD.
I'm sure by shared suit.
Shared side. CD is congruent to itself, right? It's the same for both triangles, right? Rad. Do we have enough information to solve this puzzle? Well, it looks like we have HL on the right side, right? Hypotenuse and a leg. And we have a hypotenuse and leg here, but there's one problem. When are we allowed to use hypotenuse leg? Only when what? We're only allowed to use HL when what? Mark.
There's like no other property that can be used.
Nah, you can use it when other properties can. It's when the triangles are right triangles, right? It only works for right triangles. So notice that triangle CDB we already know is a right triangle. But we don't know, I mean we do, we're going to state it, okay? But we don't know yet that this is a right triangle. We got a pretty good hunch it's going to be. Can anybody explain why we know this has to be a right angle?
As think basically.
Yeah.
Because unless it goes like this, it's gonna have to be a straight line.
Something like that.
Huh?
Wait,
Notice-
no, the triangle has three sides, so it has to be a straight line.
That's true, yeah.
I'm very stupid.
So, linear pair theorem, remember that? That's when we have two angles on a line. Linear pair, line pair, two angles on a line. We do, right? And we know that means linear pair theorem says they're supplementary, right? What does it mean to be supplementary? What's the definition of supplementary?
Add up to
180.
Add up to 180. And so if that's 90 by subtraction property, angle we don't know, plus 90 equals 180. So we subtract 90, and the angle we don't know must be 90, right? The whole thing's 180. If that's 90, that has to be 90. So by linear pair theorem, LPT, measure of angle ADC equals 90. Now, last semester, we would have written out all that stuff I said, right? By linear pair theorem, it means they're supplementary. By definition of supplementary, that means they add up to 180. If they add up to 180, I can substitute their values in. And if I can say this and this adds up to that, I can subtract and get that one of them is 90. We're skipping all that because we learned it last semester. And we're just going to say, LPT, it's 90. Right? Linear pair theorem says they add up to 180. If that's 90, then 90 is left over for the other angle. Okay? Baller. So now, do we have enough information to prove that these triangles are congruent? The left triangle and the right triangle.
Yeah.
Mark says no. You say yes.
Big, okay.
Convince Mark. How are we going to prove the two triangles are congruent? The left side and the right side.
I don't wanna.
Can anybody prove Mark wrong? The easiest way to prove a naysayer wrong is to show him it can be done. If we can't, we'll have to believe Mark, I suppose.
I'm always wrong. So like,
Is there enough information to prove these two triangles congruent?
I mean, I think so.
What do you think? It's okay.
Because there's the shared sides, the angle, and some they're both on both. They mirror together.
It looks like there should be enough, right? What theorem can we use? Mark, have you changed your mind?
No. That's what I was just saying, like, how we can make it, like, possible, like, to solve it. We have to use the Isosceles triangle theorem.
Nope. That's what we're proving. We're trying to prove that theorem, so we're not allowed to use that theorem in the proof. Does that make sense? Like, I want to give a definition of a dog. You're not allowed to be like, a dog is a dog that, right? You can't do that, right? I'm trying to prove that theorem. It should be. This should be enough information to prove that the angles are the same, right? That's what the theorem says.
Wait, you're proving that?
Cat.
Oh.
Yeah, there you go.
Oh.
That's all right.
I don't know.
That's all right. That's normal. You guys aren't used to doing this. So, there is enough information to prove these two triangles congruent. And it's by hypotenuse leg, right? Remember when we have two 90-degree triangles, we can use HL to prove they're congruent? HL means hypotenuse leg. That means if their hypotenuses match, which they do, and one of their legs matches, which they do, then we're allowed to say they're congruent. I'm going to say it again. If you have two right triangles, and their hypotenuses match, and their legs match, then you're allowed to say they're congruent. So, by HL, hypotenuse leg, we know that those two triangles are congruent. Well, let's call the first triangle triangle ACD. Now, when we label the other triangle, we have to make sure we match up their letters, right? So, A on the first triangle is made up of the hypotenuse and the unknown leg. So if I go over to the other triangle, hypotenuse, unknown leg, that makes up angle B, right? So A and B go together. Not because, oh, look, they fold. They do, but oftentimes that can be misleading, okay? C is this angle on the first triangle. It's made up of the hypotenuse and the known leg. So if I go over here, hypotenuse, known leg, C is going to match itself, right? Lastly, D is this angle down here on the first triangle. That's made up of the known leg and the unknown leg. So I go known leg, unknown leg, that's going to make up D as well here. So it turns out C and D both match each other, right? Match themselves. That doesn't always happen, but sometimes it does. Now, great, we proved the triangle's congruent. But what we really care about is proving that A and B are the same angle. So, follow my logic. If two triangles are exactly the same, they're congruent, does that mean their parts are the same? If two triangles are exactly the same, does that mean their parts are the same?
Yeah.
Yeah, right? So we have a theorem for that. We call it CCP. I'll tell you what it stands for. So by CCP. CCP stands for corresponding congruent parts. So, if you know two triangles are the same, then you know that their parts match up, right? There should be a way to match up all their parts, right? That's what this says. Corresponding congruent parts. Corresponding means they're in the same relative location, meaning that they match up, they're in the same spot, right? Congruent means they're the same, and parts are talking about the parts of the triangle. So if you know that the triangles are congruent, which we do, we just proved that, we know that their parts should match up, right? The question is which parts? Well, I'm hoping that these two parts match up, right? A and B. So corresponding means same relative location. Now this is why it's important to write our letters in the right order, because notice that A and B are in the first slide. They're in the same relative location. They're corresponding. And if they correspond, that means they're congruent. So angle A is congruent to angle B. So first we have to prove the triangles are the same, and then we can say their parts are the same. Which parts? The parts that are in the same spots. Notice that we already knew that AC and CB were congruent, right? Look at AC and CB. Are they in the same relative spot? They are. So when you write your letters correctly, you can look up here and then use CCP. Corresponding parts will be congruent. If they're in the same spot, they're the same. DA and DB will be the same. See how DA and DB are in the same spot, the two outer ones, right? Here's DA, here's DB. So by CCP, I can also say, these are the same. The parts match up. So first you prove the triangle's congruent, and then you say their parts match up. Now I don't care about any of those segments, right? All I care about is getting this, and I've got it, so I'm done. Swag box, right? Now, like a dead cat, I'm gonna back up and go over it again, okay?
What Mr. Pink does on his free time. More cats.
There you go. I used to have two.
Used to?
They're in Seattle now.
Vegan.
Huh? Where is Seattle?
Sorry, Vancouver, Washington.
My dad shot my cat.
All right, first off, we said, let there be a perpendicular line. Everybody cool up to there? You can create that on any diagram you want. Remember when we used to do like auxiliary lines for those weird angle problems?
Yeah.
If you weren't really here first semester, you don't remember that. But if you were here, we had one problem where we had to draw an extra line in the problem to solve it, right? We're drawing an extra line, we're allowed to do that and say it's 90. So says me, right? You're always allowed to do that. So we did that. Everybody good up there? Next we said, shared side. Do I have everybody up to there?
Yes.
Cool. Next we said, LPT says that has to be 90 because they add up to 180. And if that's 90, 90 is left over, right? Then we said, by HL, because now I can use HL, these triangles are congruent. Remember, HL has 3 requirements. A hypotenuse that matches, 2 legs that match, right? And they have to be 90 degrees, right? Otherwise you're not allowed to use it. So we proved that we have a 90. We proved that we have legs that match, and we were given that the hypotenuses already match. So now we can say by HL they're congruent. We have this, we have this, and we have this. So by HL they're congruent. Do I still have you? Yes? You're doing a really good job. Stay with me. Lastly, if the triangles are congruent, then their parts should match up. Question is which ones? Well, it turns out A and B do match up because they're corresponding. So by CCP, they're congruent. So CCP stands for corresponding congruent parts. When triangles are congruent, they have parts that correspond, same spots, right? Which ones correspond? These ones. If you've ever been in Sunday school, like I was as a young lad, right?
Yeah.
And you're not paying attention and you're drifting off. I almost became a preacher, still might. Okay? So, can you imagine?
That's not all.
Welcome to my church, right? Very nice. So, I'm not paying attention. Teacher, her name is Theta, I think. She's super old. She's probably dead, but if you're still alive, good for you, okay? Theta McMahon. Shout out to Theta. She'd be like, blah, 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 blah. And Derek, what do you think, right? And I'd be like, whoa. You know what I'd say? It's the answer, Jesus. And she'd go, good job, Derek. Here's a piece of candy, right? And I get her to be like, yes, thank you, Lord, right? In this class, if you're confused about what the last step is, what the answer is, it's probably CCP. Is it CCP? Good job, kid.
Like your ass.
Okay. Yeah.
One of my
So if
Sunday
you-
school
wait,
teachers
you wanna
called me a
become a
fucking
what?
idiot. Full exact words.
Well, what's the difference between a preacher and a priest?
Well,
Depends on the religion.
Oh, well, okay.
All right, so
Wait, for preachers, do they like get told people's sins in like that box?
Usually no.
Oh.
That's more of a Catholic thing.
Yeah.
Depends
for
on
I
the
remember
family.
being.
Catholic confession.
I remember when I used to go to my
It's not
dad's
Catholic,
church.
but I do know what that
one
is.
of the Sunday school teachers called me.
Although I do do
exact
this.
word. A fucking idiot.
whenever I go around and I see somebody doing bad on the test.
You probably did that by me when I was.
Number 2! Here's what we're going to do. We're going to prove the reverse. We're going to prove that given the angles, which they gave us, that must mean the sides are the same. So they gave us this. Your job is to prove that the sides are the same. Now, hint, you're going to have to use the let there be line postulate to start out, right? Then your job is to get as much information as you can about the triangles until you can prove them congruent, right? The two sides. Then, after they're congruent, then their parts should match, so their parts should match, right? CCP. Try it now. Life's not about what you do, it's who you do it with. Work together. If you have questions, I'll help, okay? This is new, it's different, it's weird. It's going to feel like floating in space. What do I do? Oh my god, I can't just follow the steps. Oh my god, right? That's fine, you're supposed to feel that way. But the good news is we're going to let you try it first, and then we're going to adjust a little bit to make you better. Isn't it the worst when your parents don't even let you try it the first time? Like, here's how you do it. It's like, no, just let me try it, right? Here, you guys try, and actually try, and then I can adjust a lot less work, okay?
Gosh, like she won't let me drive on the highway.
I know, we're only driving a highway. It's just
You're
30,
bringing back
Mom.
some really bad memories.
I don't even have my permit.
First step is to let there be line. Make it perpendicular. Josh, did you write it too? Okay, remember, to draw the line is one thing, to talk about it's the other, right? Let there be a segment such that, right? CD is perpendicular, or whatever you want to call it.
Matt, you bring back some bad memories, dude.
Let there be line.
That makes so
Right? Alright, pro tip to my first hour and third hour. Fourth hour is so nice and good at paying attention. You guys get it.
What do you got?
It's amazing how that happens. And if you don't get it, let me help.
Matt, you bring back some
get it, but we
Let there be this parallel or perpendicular. Yes, so it's
Yeah, we were
90
being in Sunday school one day. My Sunday school teacher brings us out to the hallway and says, Andrew, you're a fucking idiot.
I had two older ladies.
Sunday school.
Is that?
It's what you went to when the parents were in big church.
I never went to Sunday.
And then when you got in trouble, they'd bring you into big church. And
I
you'd
went to
know.
preschool. I didn't go to
I never got in
church.
trouble, but I went
Dude.
to the big church with my grandpa and I just fell asleep.
That's fine. My grandfather was a preacher, so I often went into big church. It was great. And then he would teach me how to open candy behind my back so I wouldn't make any noise.
Me and him,
Churches
me and my grandpa would just sleep
emotionally
together
scarred
on the
me for
pews,
life.
and my grandma would listen.
That's all it's
Yep.
done.
I have a stomach ache. Really, I'm just gonna go to bed.
What did I just do with that paper that I put away? Honestly, I don't know.
Churches give me so many
No,
emotional
I
scars
really
as a
did.
kid now.
Oh my god.
All my worst memories have come from the church.
Well, that's
They're all
unfortunate.
against it.
No way.
I was like,
I remember my
no
Sunday
way.
school teacher said, Andrew, come into the hall with me. I'm like, okay.
Okay, wait, I'm
Andrew, you're a
confused now.
fucking idiot.
I doubt it.
I never went to Sunday school. I really missed out on childhood.
All right. It seems like we don't have any questions. I'll give you a couple more minutes.
Listen, Matt,
Together. I want you to try it on your own. Come on. You can do this.
I thought you said we went together.
Well, like, without me.
Oh.
Like, I'm lost. Like, I got here, but like, if I just do the same thing as
We don't have enough information. Yeah. You're not going to be able to do HL for this one because we don't know anything about the hypotenuse because we did when we'd be done, right?
Wait,
What's the Higgs HL?
wait, wait.
It's like so boring there.
Yo, is it really? Maybe it's falling off.
Yeah, LPT.
Oh,
And then
okay,
could
but I
you,
feel like always like that.
Yeah, buddy.
Hey, watch your mouth.
What? No, I said that.
Yeah. Oh, it's a baby.
No, he's fine.
Well, they're all.
Yes.
From school or anything. I'll do it.
How do you make fun?
LPT.
Literally
Use your
just
phone to work protractor or just free hands. Doesn't have to be perfect, right? You're just saying it's 90 so 70, right? Make sure it's perpendicular, not just line, right? That's a key. You can drop a
I
perpendicular
don't
whenever you
have
want.
pictures of my dog. I have.
He's a big guy.
I'm so confused.
And we know we can drop a perpendicular whenever we want, because imagine you're at the top of the mountain.
Oh my God.
So you drop a rope down. It's going to drop at a 90-degree angle.
I just might.
Bad.
Yeah!
More bad vibes.
Killing it.
You
Alright, so that's good. Now you said
You guys wish it was 6 hours a week. I was actually quiet.
Aw, here's
back
one
up.
picture of my baby.
Because there was one kid, sophomores
They
there,
were-
and
I have a dog named
we don't really only freshmen.
Warren is the love of my life. I think I'm gonna break up my life for Warren.
prove that.
Oh,
We're doing the opposite.
No,
Very
we
simple.
more in our
Okay.
part.
You're not going to use HL though.
I kind of just like tried to figure out what I could copy down from the other one, and it didn't really work. And I don't know what I got there.
All right, work on that for homework. I'll see you tomorrow.
Now Spanish
Really hurry up,
I
McKenna.
need a sound.
She cusses me out in every single word in the English language.
Well, if you
I'm good.
might put it like that.